Good afternoon, everyone. Let us start today's session. Today our instructor is Dr. Ankit Jain. So this is the topic for today's discussion, that is Naive-based tutorial. So the agenda for today's class will be to understand first what is machine learning, and then I will explain you in detail what is classification. Okay. So which are the keywords we are going to discuss? One is machine learning, one is classification. After that, we'll come to the main, I will say the main hero of today's presentation, that is Naive Bayes. We will understand why we call it Naive and from where does Bayes come. Okay, so let us have a good discussion over it. At the end, I may give you some glimpse of how Naive Bayes calculations are done. And so this will be a short webinar where we'll have a good friendship with Naive and Bayes. Okay, so today's agenda will be basically to get familiar with Naive Bayes and to see its scope in machine learning. So let us first come to today's first understanding what is machine learning, right? Machine learning explores the study and construction of algorithms that can learn from and make predictions on data. It is closely related to computational statistics and used to devise complex models and algorithms that lend themselves to a prediction, which in commercial sense is known as predictive analytics. Okay, so I think most of you know that, right from our childhood, a lot of us have come across weather predictions. Right now, most of us are using face recognition on our mobiles, where our mobile phones open up when they see our face, right? Also, a lot of speech recognition work, speech based chatbots we are using, in terms of Google or Alexa or Siri, we have been coming across that, right? So if I may explain you, basically machine learning, okay, they are a way to put or create AI. Is it clear? Machine learning is one of the methods through which we will create AI, that is artificial intelligence. Okay. Now, how do we create artificial intelligence using machine learning? What is the main criteria for that? So, the main criteria for creating machine learning is data. Now, this data may be in the form of numbers, in the form of images, in the form of text. Is it clear? The machine or the data may be in the form of numbers, images, and text. When this number, images, and text, numbers, images, or text go into an algorithm, okay, the algorithm basically means what? It is a set of equations. Okay, and when you tell them that from this number, images, or text, you give them, you tell the algorithm this is you. So all of you, I have made you now very thin today. So this you will tell the algorithm mathematically that from this number, images, text, my area of interest is, you will tell the algorithm the same thing. Once you tell this, the algorithm will automatically understand what is the relevant part I need to learn from these different forms of data, number, images, or text. Okay, so once this algorithm is trained, okay, this is known as basically machine learning. So what you have done, you have made an algorithm learn that from the given text, from the given images, or from the given numbers, this is my area of interest. Please learn that. The algorithm will solve the set of equations and get itself trained. This phenomena is basically known as machine learning. Okay. Now, how many of us want to become a data scientist here? I think most of you want to become a data scientist, right? So the role of an data scientist is to understand this algorithm. It is assumed you will be an expert on this. Okay, you exactly understand what an algorithm is, why it should be used, when it should be used. Okay, so a data scientist knows when to use which kind of algorithm. Okay, so this is the role of us. Okay, so now with this understanding, let us understand different types of machine learning. What are different types of machine learning? Okay, so theoretically there are three types of machine learning algorithms. Okay, the algorithms which are used for machine learning can be divided into three types. Algorithms used for machine learning can be divided into three types. One is supervised learning, we have unsupervised learning, and then we have reinforcement learning. Is it clear to everyone that in machine learning, basically the algorithms which we are using in order to train the algorithm with different kinds of data, those machine learning algorithms can be divided into three sections: supervised learning, unsupervised learning, and reinforcement learning. Okay, out of this, the main ones which are being used right now are supervised learning and unsupervised learning. Okay, now the question is, machine learning, suppose I make it simplified for you, are two types: supervised, we are ignoring reinforcement for now, unsupervised. Right now, what is supervised learning? Supervised learning is, so as I explained you before, the whole art of machine learning is feeding in data. Okay, input data, we call it input data. So suppose I tell that mathematically input data is represented as x. Okay, and from this input data we feed it into a machine learning algorithm. Okay, and it will predict a y, it will give a output. Okay, to make it easier for you all to understand, suppose you have, I'm sorry for this, suppose you have made a graph which gives you a relationship between stock price and the date. I think I need to make a better graph. I'll just do that. Suppose we are creating a graph that is between stock prices. Let me name the stock price, say Edureka has a share, and we want to see the behavior of Edureka with respect to date, right? 4th of November. And we know the prices till today. Suppose these are the prices of Edureka share prices, some dollars, right? Suppose we feed this data into a machine learning model. Okay, it can be used now to predict for next day, that is 5th of November, 6th of November. Suppose it can be used for doing that. Now, how many of you are understanding that if a machine learning model has been trained from historical data and it can predict the prices for tomorrow, can you imagine how much money we can make out of the share market, right? We exactly know whether the prices will go up or down tomorrow. Okay, so in this case, this is exactly what is machine learning. Now in this case, So SL is unsupervised learning, sorry, supervised learning, USL is unsupervised learning. In this case, you feed in the X, okay, and if your Y is known, you exactly know what I want to train the model on. What is my target variable or my output? If that is known to you, okay, then it is known as supervised machine learning models, okay. And if you are feeding in X, that is your input data, but you into a machine learning algorithm, but you have not told it what Y I want. You have not told it what Y I want. So target, if it is not defined, what will be the machine do? The machine will automatically learn the pattern. It will learn the pattern itself. Okay. In that case, it is known as unsupervised learning. Okay. It is something like this, that when we are small kid, our teachers will guide us. Okay. They will give us the why, that you need to reach from year to year. They will guide you at every step. But when we go into college, right, we are just given input that all these things you need to do. They don't tell us where you need to reach. They will leave us unsupervised. Okay. Why? Because we have grown up, we are trained now, and we can handle ourselves. Okay. Now today, let's come to today's focus. The focus of today's class, is supervised learning. Okay. Now in supervised learning, as I explained you, again in supervised learning, there are two types: regression and classification. What is it? It is regression and classification. Okay. Today we will learn about classification. Okay. So first, let me lay a foundation for you. What is classification? How Naive Bayes can be applied to classification. Is it clear? This is what we are here to understand. So this is what exactly I have explained you till now. That in machine learning, as I explained, there are basically three branches theoretically, but in general, we tell that machine learning consists of supervised learning and unsupervised learning. In supervised learning, the target is labeled, or the features are labeled. Anyways, classification is the result of supervised learning, which means that there is a known label that you want the system to generate. Okay. So basically, as I explained you, X converting to Y is known here. You know exactly what you want to predict from your X. From your input, what you want to predict is known. In unsupervised learning, we don't do that. We don't predict anything. We just say, in this X, how many groups are there? Okay, so that's a technical word for it, is clustering. All of you please say it loud: clustering. So basically we do what? Given an input, how will we cluster the data into different groups? That is what we are going to learn, okay, in unsupervised learning. Today we are going to understand in supervised learning classification. So what is classification? Classification in layman terms means what? You have a set of data, let me call that input data X. Okay. Now from this input data, you want to give or classify that with an example. Suppose you have an input data of a person, say his bank score. You know that there are CRISIL score, credit score, a lot of scores are there. Suppose you give that as an input to a machine learning model, and it has already been trained on historical data. So it needs to predict whether you should give loan to this person, yes or no. Okay. So based on this input, what your machine learning needs to predict, yes or no. Okay. Similarly, when you do face detection, suppose in your mobiles, so if you put if you put your face in front of your mobile, the mobile will learn your face and will take a decision whether it should unlock your mobile, yes or no. Okay. Similarly, if I give you say yesterday I was solving one problem where I need to say whether a banana is ripe, unripe, or overripe. So how many what was I giving to the machine learning model? My input to that machine learning model was a picture of a banana. Sorry for the bad drawing. Yeah, let me write it, otherwise you will not understand that it's a banana. Now I feed it to a machine learning model. It needs to tell me whether this banana is ripe, unripe, or overripe. How many categories are there in this problem? Have I defined any category in this problem? Yes, 3 categories. The key word here is I defined that my banana can be classified into 3 categories. Okay, so this is a technical word. When you say your X input needs to be divided into categories or categorical data, okay, then in that case, it is known as classification. Okay, so basically when your input is to be divided into yes or no, or say male, female, say into different buckets of fruits, etc., then in this cases we will say that it's a classification problem. Okay, like is this A or B? Will it rain tomorrow? The answer will be yes or no. Which animal is this? So we will have to define the number of animals. So it may be a tiger, lion, or a cat, right? Or a dog, right? 4 categories we have defined. Is the transaction fraudulent? Yes or no, right? Such kind of problems are known as classification problem in machine learning. Okay. Now, which are the classification algorithms? So now you know that which kind of problem you are going to face today. You're trying to solve a classification problem. So first you need to know what are the tools or algorithms available in order to solve a classification problems. They are linear, decision trees, support vector machines, neural networks, kernel estimation, and quadratic. In linear, again, you have Naive Bayes, logistic, and perceptrons. How many of you are understanding? These are different algorithms which I can choose in order to train the model to predict what input data belongs to which categories. Okay, today we are going to learn about Naive Bayes. This is the thing we are going to learn about. So what is Naive Bayes in short? Naive Bayes is a algorithm used for classification. Or if I can give a statement, Naive Bayes algorithm is used for solving classification machine learning problems. So if you ask me what is Naive Bayes, for me it is very simple. It is a probability based algorithm and it is a sophisticated way to do counting, nothing else. It is a sophisticated way to do counting. Okay, let us understand it with this example. Suppose you are given a problem statement that I give you weather condition today. What is the problem statement? I am giving you weather conditions today and you have to tell me whether this is appropriate to play football. Yes or no? I am going to give you, what is my input? My input is I am going to tell you the weather conditions today and you need to tell me whether it is a good time to play football or not. Okay, it looks like a very simple problem, doesn't it? But it is not a simple problem. Okay, it has lot of layers into it. Let's see what are the layers now. Okay, you have been given a input of weather conditions today Okay, and based on that weather conditions, you have to say today whether it is a good time to play football or not. Okay, it is a super. And other thing I told you, key takeaway was Naive Bayes is a very simple machine learning algorithm, which is nothing but a sophisticated way to do counting. Okay, let us understand it very simply. Okay, so now it is not so linear problem, right? There are lot of ifs and buts. Now what are the ifs and buts? Let's understand. Okay, now here if I draw a probability, suppose it is summer. Okay, the probability of playing football, okay, if it is very sunny, also it is summer and plus it is sunny. Okay, would you want to play football in this situation? Would you want to play football in this situation, that it is a summer time and it is also very sunny? So how many of you would like to play football there? The probability will be more towards the no side. Can you see this? Right? So the probability is more towards the no side. So what is this dot showing? It is showing probability. Okay, I will explain you how we calculate probability, but probability of you playing on a given day when it is sunny and it is summertime, the chances of you playing football are very high. Sorry, the chances of you not playing football are very high, and the chances of you playing football is very low. Okay, there are some chances, but it will be very low. Can you see this now? Monsoon, it is monsoon now and it is sunny. I'm sure most of us would like to go and play at that point of time. The probability of playing is high, correct? And the probability of not playing will be low. Why? Because if it is not sunny and it is monsoon, most probably it will be going to rain, right? Similarly, if it is winter and it is very sunny, the probability of you playing uh, football is high. Now the question is, how will you quantify this? How now you need to, suppose I am asking you a question, please quantify probability that today it is sunny. Okay, what is the condition given to you? That it is sunny and it is winter time. What you need to give as a data scientist, I am asking all of you, please quantify for me what is the probability of no. What is the probability of no given the weather conditions are sunny and winter? Okay, this is the question you need to answer. So let me write this so that you understand. Okay, what is the probability of you not playing football given the conditions are sunny and the other one is what? It is winter time. Okay, it will not be 0 or 1, it will have a value between 0 or 1. You need to quantify that. Okay, this is what exactly Naive Bayes will do. Okay, Naive Bayes will quantify this for you. Okay, Naive Bayes will quantify this for us, that hey boss, today you want to play football, what are the chances that you will not play football given it is sunny and winter? Once you quantify, say not playing, right? Suppose you quantify not playing, it comes out to be say 0.05, and Naive Bayes you can also use to see what is the probability of yes. Suppose it comes out to be 0.4. Who wins here? Who wins here? The yes wins here, right? So you will classify it as yes. Okay, So the whole money is understanding how Naive Bayes can be used to quantify probabilities. Okay. Now this is not normal probability. Why this is not normal probability? I'll explain you. Suppose I ask all of you, I am tossing a coin. I am tossing a coin. Suppose I tell all of you I am tossing a coin. What is the probability I will get head? What is the probability I will get head? That it is 1 by 2. Right? It is 0.5. Correct? So did I put any condition on you? Did I put any condition on you? No, I did not put any condition on you. But let's think about second scenario, that please toss a coin. Okay. And when you're tossing a coin, I will say that, you have put a condition on the coin such that it will always, or say the head side is heavier. If I say, what is the condition you have put? That the head part of the coin, I have made it little heavier. Okay, something of that sort, some manipulation I've done. Now tell me what is the probability of head. Okay, now tell me what is the probability of it. So this cannot be answered straight away by 1 by 2. You will have to look into this factor, right? This is a condition, right? Like in this case, what was the condition put on that? That it is sunny and it is winter. Okay, so if it is sunny and it is winter, that's a condition given to you. Okay, in that case, what is the probability? Then we will use Naive Bayes. Okay, so Naive Bayes is used for conditional probability, right? So can you see this now? There is a number here. Okay, if there is a number here, who gave this number? We got this number from Naive Bayes. Okay, so let us now understand how this calculation is made. Okay, great. All of you, would you like to learn how Naive Bayes does calculation? Let us understand that. Okay. Similarly, if I ask you the same questions, today it is sunny, no. What is the condition today? See, so many probabilities are there. This was for condition 1 of sunny. This is for condition 2, that today it is windy. Okay, instead of sunny, it is windy. Then it is not sunny and it is windy. Okay, and it is not sunny and not windy. Okay, what I'm trying to tell you is there are so many attributes or so many different conditions you can put. So many different conditions we can put, right? So we need to understand, based on these conditions, how will the probabilities change? Okay, so if you see here, if it is sunny, yes, and if it is windy, yes. If it is summer, monsoon, or winter, all the time is an ideal condition to play football. If it is sunny, yes, and if it is windy, no, then monsoon is the best way to play football. Okay, so these are different conditions, and using Naive Bayes, we are just putting some numbers onto it. Let us understand now how do we quantify these numbers. Okay, so for that we are using something called as Bayes theorem. Okay, so Naive Bayes classifier is a simple probabilistic classifier based on applying Bayes theorem with strong independence assumption between the features. Okay, so this is a mathematical formula. This is a mathematical formula. Who gave this formula? It was given by the great scientist Bayes. So that is why it is known as Bayes theorem. Okay, so Bayes theorem, in Naive Bayes, the mathematical equation used to find the probability on conditions is given by Bayes. That is why Naive Bayes theorem. Now Naive, why the word Naive? Because if I can get little technical, Naive has come into picture because it is the assumptions which have been made in order to do this calculation are very simple, are not actually very realistic. That is why it is known as Naive. Okay. Now let me just write it down for all of you so that you can understand it better. Naive Bayes theorem or Naive Bayes is based on the Bayes theorem for probability. Okay. The word naive is because it is assuming. So whenever you make some algorithms, there are some assumptions made. The assumptions made here are very simplistic. It is assuming very simplistic assumptions. Okay. That's why we say it naive. And that is the reason why we do not much use it in industry. Okay. This is a little technical definition. All those who are new, don't worry about it. But those who know about it, I'm just giving you one extra information that why I'm not using naive Bayes in industry, because the assumption by which it calculates the probability, those are not very true to real life. That's why we don't use it. But even then, it does a good job. Okay. So now let us understand technically what is Bayes theorem. Okay. So Bayes theorem is essentially where you calculate likelihood. This part is known as likelihood. This part is known as class prior probability, and this part is known as predictor probability. So in order to calculate this part, you should know these three things. Okay. Now this may look like very alien to a lot of you. Let us understand it with the example now. Okay. So this is the table which has been given to you. This is the table given to you. What is the table showing? It is given to you. It is showing the historical data. Okay. The historical data given to you is that it is sunny. Okay. In that case, how many times did you play football? 3 times. Okay. And how many times you did not play football? 4 times. Okay. Let us look at this one. Okay. Let us look at this one. How many times it was summer? First, concentrate on this table. It was summer. How many times you played football? 3 times. And how many times you did not play football? 2 times. Okay. It is monsoon. How many times you played football? 4 times. And how many times you didn't play football? 0 times. Winter. How many times you played football? 2 times. And how many times you did not play football? 3 times. Okay. Now, based on this table, which is the best season to play football? Obviously, the best season to play football, as pointed by all of you, is monsoon. Why? There, all the time you played football, you did not play a single time not played a football, right? So monsoon is easily the winner here. And which is the loser here? Winter, right? But the story doesn't end here. As data scientists, we need to quantify what were the conditions in which we did not play and what were the conditions in which we played. Okay, what were the conditions? We want to understand that. Now in summer, I told you there are 2 conditions, sunny and windy, right? There are 2 conditions, sunny and windy. Now let us understand it in details. Let us understand it now with probability terms. Okay, it is summer. What is the probability of you playing? Suppose I tell you today is summer. I tell you today is summer. What is the probability of you playing football? Yes. What is the probability that given it is summer, what is the probability that you will play football? The answer will be what? 3 plus 4 plus 2, which will be 9. Okay, so 3 divided by 9, that will be the probability of you playing football given it is summer. Okay, so this gives you probability of, this gives us what? Probability of we playing football, yes, given it is summer. Okay, all of you please concentrate on this term. Right? What is the condition here? The condition is summer, and I am asking how much is the probability that given it is summer, I will play football? That is 0.33. Okay. Similarly, what is the probability of me playing Football, when it is monsoon, it will be what? 4 divided by 9. Winter, 2 divided by 9. What is the probability of you not playing football when it is summer? It is 2 by 5. How did you get this 5 here? You got it by adding all the no's. Probability of you playing monsoon or not playing football when it is monsoon is 0 by 5. Probability of you not playing football when it is winter is 3 by 5. So what is this? Probability of yes here is 9 by 14 and probability of no is what? 5 by 14. This is the complete probability, right? Out of the 14 times, how many times did we go to play football? 3 plus 4 plus 2, 9, 9 plus 5, 14. So there were 14 times we wanted to play football, out of which 9 times we played and 5 times we didn't play. So the probability of yes is 9 by 14. Probability of no is, overall no is 5 by 14. Okay. Now what do we want to learn? We want to learn that what is the probability of yes when it is summer? So today, okay, so all these calculations you have done. Now let us understand this. What is the probability of no that you are not going to play football given the conditions are it is not sunny, the sunny condition is no, and the windy condition is yes? That we are going reverse now. That given a new condition that today is summer, today it is given that it is a summer, right? Then what is the probability of yes that you will play football given it is summer? So the answer for this will be given to you by Bayes theorem. Bayes theorem says that if you want to calculate probability of yes given it is summer, then historically you need to see that how many times you played when it was summer into what is the total probability of yes divided by the total probability of summer. Okay, so this is what we will look into. Okay, so we do this calculation and this calculation will be 0.60. So what is the probability that today you will go to play football given it is summer? The probability is yes. The probability is 0.60. Okay. So similarly, as I told you here what is asked of you as a data scientist, what did your customer ask? That what is my probability today to play football given it is winter? Okay, it is winter. Given it is winter, it is not sunny and it is windy. Can you quantify for me with how much is the chances that I will play football, yes or no? Or only for yes. Okay. So for that, the formula we use the Bayes theorem, which is P of winter divided by yes into P of sunny equal to no divided by yes. This is conditional probability from previous data. Similarly, this into P of yes into P of winter into P of sunny no into P of windy yes. So I'm not going into the details of it. You can have a look. You just need to fill this numbers and it will give you a number. So now you have quantified it based on Bayes theorem. That the probability of me playing that today it is sunny and it is windy and it is a winter time is 0.623. Okay, quantification is done. Okay, so this is how you calculate for different conditions in your data set what are the probabilities using Naive Bayes. Now it is very simple. Once you calculate that, so suppose probability of yes you playing football when it is summer is how much, say 0.6, and probability of no when you playing of you not playing football when it is summer is say 0.4. Who wins here? It is yes. So your machine learning model will say yes, that today is a good time to play football. Okay, today is a good time to play football. Let us also do one more calculation. What is the probability of you finding king in a deck of cards is 4 by 52. It is equal to 1 by 13. So this is the probability that you will find a king of cards in a deck of cards is 4 by 52 or 1 by 13. Okay. Similarly, I ask you now that you are picking one card, okay, and that card is a face card. You know what a face card is? Face card is J, K, Q, and I guess A also. I don't know. I think A doesn't count as a face card. So J, K, and Q in your deck of cards are your face cards. So what is the condition given to you? The condition given to you that you have already got a face card that is known. Now what is the probability that you have a king inside it? Okay, so we will do what? We will first find the probability of a face card in which king is there, divide by probability of face into probability of king. How did we get this? We get this from Bayes theorem. Now this we know, probability of king is what? 1 by 13. Probability of face card is what? How many face cards are there in a deck? In a deck, jack, king, and queen. The probability of face card P of face will be how much? Every set will have in a set, I think there are 4 colors, right? In 4 colors there are 3 face cards, so total you'll have 4 into 3 face cards, divide by total 52, which will come out to be how much? 3 by 13, right? So using the Bayes theorem, what we will do, we will just put 1 by 3 divide by 13 is equal to 13 by 3. So this will be our answer, that given a probability that it is a face card, what is the probability of you finding king? Okay, in that case we will find out using the Bayes theorem. Okay, I think you may want to revise or spend more time on this. That is my suggestion to all of you. Okay, now I hope the basics are very clear. The mathematical part may require some more understanding or some more, I will say, practice. Okay, the last key takeaway for you will be, these calculations are not done by us. These calculations of finding probability is not done by us. Who will do this? It will be done by machine. Okay, that's why it's a machine learning algorithm. But what are we understanding? That machine at its back end, okay, what it will learn, it will use Naive Bayes in order to calculate probability and say or classify. Are you all understanding? The machine at its back end, when you tell that please use the Naive Bayes theorem, it will do the calculations which I just showed. Now just imagine if you have 1 million rows of data, and here we had only 2 conditions, sunny and windy. Suppose there are more than 20 conditions, humanly not possible to do the calculations. Who will do the calculations for us? The machine will do the calculations, and it will do it within split seconds. Okay, so Naive Bayes is used when we have to do classification, and the machine can do it very fast. Okay, the advantage of using Naive Bayes is it is very simple method. You see that there was no complication here, and also it is very fast. The calculations are very fast compared to other complex classification algorithms. Okay, great. So with this, I will end today's session. I hope you enjoyed. Thank you all. Have a good day. Bye.